He invests his money at a rate. Remember, whenever you see one of these special words, like quarterly, annually, semi-annually, monthly, daily, this is where you need to know what this word means. When you did the WebAssign homework a long time ago, that was my n value, and they just told you, do it when n equals 1, when n equals 4. So this is where you need to memorize the words. Quarterly means 4 times a year. The formula I'm using, whenever it's going to be compound interest during a certain amount of time, the formula I'm using is A is equal to P 1 plus R over N raised to the Tn power. Remember A, this is going to be the total amount in the account. So the money in the account after interest. So this will be the total amount. So total amount, let's see, total money in the account after the interest is earned. The P, this is the principal. And this is money. And this is the invested amount. The R is the percent, the rate. The N, this is the quarterly in this particular problem. And then the T is the time, and it's always in years. Again, you can review these notes if you need to. This N is the same. So now what we're going to do is fill in our information. So they gave us the P. The invested amount was $25,000. My R was quarterly, so my R is 0.75. Now this is percent. Remember, when you use it in the formula, you need to convert this to a decimal. So I need to move this 2 times to the left. So the rate that I'm going to be using on the problem is 0.0075. My N value, that's the quarterly, that's the 4. And the time in this problem is 6 years. I'm going to be filling in all of these variables with their amounts. Now, if you have the TI-84 calculator or 83 and you want to enter something as a fraction, you can hit the green button and then the y equals, and it opens up a fraction for you. So again, you should be playing around with your calculators, but let me just fill everything in. So A is equal to 25,000 times 1 plus 0.0075 over 4 raised to the 6 times 4. You could key this all in your calculator. Just be careful with parentheses if need be. Once we do this, what ends up in the parentheses is going to be 1.001875 and then to the 24th power. So you'll multiply this first, or raise that to the 24th power first, and then times it by 25,000. So at the end of 6 years, his investment of $25,000 will now be $26,149.59. Remember, this is all money, so you should be rounding to the hundreds place. So be able to find a future value. How much will be in the account after a certain amount of time? Everybody good? This is what we already did a long time ago. Memorize that formula. Practice with your calculators. Again, you can key the whole thing into your calculator straight away if you want. You don't have to do it step by step. Pretty good on that? Now I'm going to do one with the other formula where it says compounded continuous. Then I'm going to go back and do, actually let's just work with this one first. Now this is what we already did. We did not do problems where we had to find the number of years or the interest rate. We also have to be able to solve problems like that. And that's what I'm going to do now. We did not do any in the notes. We did not do any in the homework. So this is why it's very important that you're paying attention right now as I go through these examples. All right, everybody good so far? I'm going to add a new problem, and we're going to do now I'm going to change the problem. New problem. New question is this. Okay, so when it says how long will it take, our goal here is to find t. So again, let me write down the formula that we're going to be filling in. So we're doing A is equal to P 1 plus R over N raised to the NT power. So my goal here is to find the number of years. So what I'm going to do is fill in my given. And this is what you're going to be doing on the test. You're either going to be finding a time or a rate. So we're going to be filling in. So the future value that I want to have in my account is going to be $5,000. I only want to invest $3,000. And then it's 1 plus. Again, I need to turn this 2.5% into a decimal by moving it 2 times to the left. So 0.025. And then monthly means my n value is 12. And then I'm raising this to the 12t power. Now, what I'm going to be doing here is turning this into an exponential. And then I can either use Bay or I could add log to both sides. But the first thing I'm going to do is get rid of the 3,000. So I'm going to divide both sides by 3,000 because I want to isolate the exponent. So then this just cancels. So then I'm left with 5/3 is equal to 1 plus 0.025 over 12 raised to the 12t power. Now, this is actually an exponential form. So if you want to do the Bay trick, what we can do here is, let me just move it around. 1 plus 0.025 divided by 12, 12t equals this. What we could do is turn this into log, or what we could also do is take the log of both sides. If you wanted to turn this in, this is the base, this is the exponent, this is the answer. I could do the math here, simplify this. Let me go ahead and do that. I would just do this continuous on your calculator. This would be 1.002083. It's going to be 3 repeating. Raised to the 12t power equals 5/3. So then what I can do here is go ahead and turn it into log form. I could do the log of this crazy long number. Equals, so answer and I can solve it this way. This is one way. The other way would be to take this and we're going to add ln to both sides. So what we would do is ln of 5/3 equals ln of this crazy long decimal. So once I did this, this was this. So I'm doing natural log of 1.00208, repeating. And then that's raised to the 12t power. Then what we can do is use our power property, move it to the front, So ln of 5 over 3 equals 12t. ln 1.0020833. And now what I can do is solve. I want to get this by itself, my t. So I'm just dividing both sides by 12 ln 1.0020833. Same thing over here. And you could do this continuous in your calculator. And then this cancels. And then you're left with t is equal to 20.49 years. If we round it to the tenths place, 20.5 years. That's how long it would take. If you did it over here, what you would do is get this number on your calculator and then divide it by 12. If you use this technique by turning it from B to B. So then here you would just divide by 12. And you could do this continuous on your calculator. Either way, you should be getting 20.5. So be able to find the number of years that you would have to invest something. So the other formula, that was the PERT formula. So let's do that one. So again, I'm going to add another question here. I'm going to use the same person, Sunny. Sunny wants to have $20,000 for a vacation. That he wants to take. Sonny wants to have $20,000 for a vacation that he wants to take in 5 years. How much does he need? So Sonny wants to have a vacation or take a vacation in 5 years from now. How much money or how much does he need to invest today if his money will be compounded continuous at a rate of 3.1%? So keyword here is compounding continuously. When you see those words, we're going to be using the formula, the PERT formula, A equals P times E raised to the RT power. So we're looking for the amount that he needs to invest, the P, because the 20,000 is going to be the future value. So up here, this is my A value. This is going to be my time. And this is going to be my rate. The 3.5%, the 3.1%, but I got to make it a decimal. So I'm going to make it 0.031. So now let me go ahead and fill in. So I know that we need $20,000. We don't know the P. E is the button on our calculator. And it's going to be raised to the R times T. So 0.031 times the 5 years when he wants to take his vacation. Now, my goal here is to solve for P. So really all I'm doing is dividing both sides by E to the 0.031 times 5 power on both sides. So this is all I'm doing to get my answer. So once I do that, and if you want to enter it as a fraction, remember if you have the TI-83, hit alpha y equals, and then press option 1, and it'll let you put it in as a fraction. And then you're going to move the cursor down. Then I would hit the E with the exponent button, which was my LM button. I hit the second key. And then I'm going to multiply 0.31 times 5. And I get, he will need to invest $17,128.30. This is how much his initial investment will be in order to get it to $20,000. So all I'm doing is on my calculator, I opened up the fraction. So I can show you how I entered it. Again, if you want to do it step by step, you can do that as well. This time I want to invest $6,500 for 3 years, or 3.5, sorry. 3.5 years. And I want to have $10,000 if my interest is compounded continuously, what percent, or let's see, what I just want to find R. Let me just put it like that. Find the rate if it's compounded continuous. So I'm looking for R. So let's go ahead and fill it in. We're using the same formula we just did. I'm using my PERT formula. So I'm investing $65,000. This is my P. 3.5, 3.5. This is my time. And then the 10,000, that's my A value. I'm solving for R. So let's fill it in. So I'm going to fill in 10,000 is equal to 6,500 times E. I don't know the R, and my time is 3.5. So now I can do this 2 ways. I can either convert it from exponential into log, or I can take the log of both sides. But you need to isolate the exponent first. So what I'm going to do is divide both sides by 6,500. Chop off some zeros here, but you're using a calculator. So now what it is it's 100 over 65 is equal to E to the 3.5 R power. So you can either choose to just take the natural log of both sides, ln, ln, and then what we're going to do here is, in order to isolate, all we need to do is divide both sides by 3.5, because I can pull this power down to the front, if you want to see it that way. So then it's just ln, because lne would be 1. So now I have ln 100 equals 3.5 R times lne, which just becomes a 1. So then now I have natural log of 100 over 65 equals 3.5 R. Divide both sides by 3.5. And whatever we get on our calculator from this is our answer. It's going to be 0.123. We need to turn this into a percent. Move it 2 times back. So round it to the tenths place. You need to invest it at 12.3%. On the test, it'll be round to the tenths place. The other way that you could have done this is, once you got this, 100 over 65 equals E to the 3.5 R power. This is exponential. I can move this over here. If you want to divide this, you could. So 100 divided by 65, it's a crazy long decimal. I'm just going to leave it like that for now. I could turn this into bay, because right now it's B. I could do ln, because the assumed little base here is an E, and then 100 over 65 equals 3.5R. So then essentially all you're doing is dividing both sides by 3.5. So again, key this in your calculator, hit the ln button, and then fill in 100 over 65. You could do the alpha y equals to get the fraction, and then do divided by 3.5. And then you should get this decimal, but then you got to make it into a percent.